In this video I'm looking at the solution to question 7 of the January 2011 Edexcel D1 paper. The topic of the question is critical path analysis. In the question we're given a network in a figure which shows the activities needed to be undertaken to complete a maintenance project. So the activities are represented by the arcs, and the numbers in brackets are the time in days to complete the activity. The numbers in the circles are the events. As each activity requires one worker and we need to complete the project in the shortest possible time. In the first part of the question has to complete the precedence table, which is in the answer booklet if you're doing the exam, and explain why each of the following is necessary: the dummy event from event 6 to 7, and then the dummy from event 8 to event 9. The question then goes on and asks us to complete diagram 2 in the answer booklet to show the early and late event times. And having done that, to state the critical activities, and then calculate the float for activity K, and finally to complete, to calculate a lower bound for the number of workers needed to complete the project in the minimum time. Well, first of all then, looking at the activity network, we can transfer that onto the precedence table. So we can see that this has already been started. So for C, then activity A precedes it. So this is looking at event 2. And likewise, we can going on from that for D and E. These are also preceded by A. F is preceded by B and C, so that's looking at event 3 there. So going forward then for G, we can see that also comes from event 3, so therefore that is also going to be B and C. H, well, that comes from event 4, so that is E and F. I follows on from 5. Now there's a dummy in there, so for I, as well as the obvious one D, we've got to come back to event 4 as well. So we can see there we've got E and F. So for I, there's D, E and F. For J, that comes from event 6, so going into that are H and G, so G, H. And for K, this is from event 7, so again we've got I coming directly into 7, so that precedes K, but also we've got a dummy going down to 6, so here we've got G, H and I. And similarly for L, there is G, H and I. We're asked to say why we have particular dummies in there. So the dummy from 6 to 7, so the dummy from 6 to 7, well, we've already described that in doing the precedence table, but this is because J depends on G and H only, whereas K and L depend on G, H and also on I. And then the dummy from 8 to 9, Well, that's because you can't have two activities coming from the same start and end point. So without that dummy, we would need K to go from event 7 and then linking in to, actually it'd be L I suppose, going from 7 linking into L. But that's not allowed, so that we show that it's because then K and L cannot share the same start and finish. Okay, the marking for this part of the question went as follows. It really depends. There were 3 marks available for the precedence table, and they were allocated as either getting 3, 2, 1 or 0 marks in here, and it really depended on whether you had 2, 4 or all rows completed correctly. So there's B1 for getting 2 rows, 2 marks for getting 4 rows, or if you had all of the rows completed correctly, then 3 marks. The marking for these dummy explanations was 1 mark or 2 marks, and that depended on the clarity of the explanation really. And finally, another B mark for the second of those explanations. In the next part of the question, we're asked to complete the early event time and the late event times on the diagram, or in other words, to perform what's called a forward pass, and then once we've done that, a reverse pass through the diagram. So we always start off then with 0 at the first event, and then finding the longest path through the network to any particular event. So starting off with A, then obviously there's only one way of getting there, so that's going to be 4. But if we look at the event down at the bottom here, B would give us 6. However, we needed the longest time required, so from going A and then C gives us a value of 7 at that point. Again, continuing forward, if we look at this next one, going where from the 4 at the top using E would give us 8, but then from the 7 at the bottom point there plus the 3 gives us a value of 10. Looking where along the top of the diagram where D is, then 4 plus 7 there gives you 11. The dummy putting in there is not going to make any difference, so that is the largest path there is 11. And jumping down to the bottom of the diagram, both of the routes that we could take there, taking from 10 plus h is 2 gives us 12, and the 7 plus 5 also gives 12, so that gives us a value there of 12. Looking where the dummy goes from that 12, well, that would put 12 into the early event time there. However, 11 plus the 3 for I gives us 14. And obviously then onto that 19. And then looking at the final event, 3 different routes get into this one here. The 19 with the dummy, 14 plus 3 is 17, but then also you've got to remember then we've got the 12 plus j is 9, giving us 21. So the longest path there is 21 to that point. Working backwards through the diagram, and this time we're looking for the smallest number. So from the 21 with that dummy in there, then that would be 21. And working back, 21 take away 3 gives us a value of 18, but look at this, 21 take away the 5 there, it gives us 16. So the smallest value we can have there is 16. 21 taking away the 9 gives us a value of 12 for this event. Going up the top of the diagram, 16 take away 3 is 13. Then looking at this one in the middle here, two different routes to that, 13 with the dummy, or 12 take away 2 is a value of 10. The bottom diagram, the bottom event here, then 12 take away 5 is 7, 10 take away 3 is both of those giving you 7. And then up to the top, 7 take away 3 is the smallest one there, which is 4, and finally 0 at the end. So in total there were 4 marks available for that part of it. An M1 and an A1 mark. The M1 for basically getting increasing values going from left to right, and the A1 for getting the early event times completely correct. And similarly working backwards, M1 and A1. We're asked to work out next the critical activities. Now critical activities join critical events together, and a critical event is where the numbers are equal to each other, the early time and the late time. But you have to be a little bit careful. It's not every single activity which is going to be critical. However, working through the diagram, then we can see that from the first event up to the 4, that one is critical, so A is a critical activity. Then C is also a critical activity, and then there are the critical path splits now, going via F and H, and also then along from G, and then finally we're coming up here, J, up to the final route there, the final event. There's one activity which is not critical, this one here, even though it joins together two critical events. You'll see that that one, E, is not a critical activity because 10 minus 4 is 6 and it's not equal to 4. So you have to have 0 float time. So our critical activities are A, C, F, G, H and J. We're asked to calculate the float on K. So the float time on K, well, it can start at 14. It has a length of 5, which takes us to 19, but we can finish as late as 21. So we've got 21 minus the 14, so that's the late time minus the early time of the event before, and then minus the duration 5, gives us a total of 2 as the float, and that was in days. Then the final part of the question was to work out the lower bound for the number of workers needed to complete the project. Now the lower bound would be to work out the total time. So if I work out the total time in here just by adding them all up, we find that it's 54 days. We know that the length of the critical path is 21, so we can take the 54, divide it by 21, and see that if that comes to 2.57, and therefore we're going to need 3 workers at least. For that lower bound value. Well, looking at the marking for those parts, then there were 2 marks for the critical activities. B1 if there was at most 1 error, and second B1 if there are no errors at all. The float, M1 for the method and A1 for the answer 2 days. And again, method mark M1 and A1 for the 3 workers for the minimum number. Well, that completes the solution to that question. Other solutions can be found at www.furthermaths.org.uk.